Welcome back to another professional development presentation by Education in Nutrition. I'm Sophie Blackmore. I'm an accredited practicing dietitian, and today our guest is Assistant Professor Courtney Peterson from the Department of Nutrition Sciences in the University of Alabama at Birmingham. Courtney's research interests include intermittent fasting, circadian rhythms, food groups, and mathematical modelling of metabolism and body composition. The overarching goal of her research is to develop novel dietary interventions to treat type 2 diabetes, obesity and cardiovascular disease. Courtney recently conducted the first controlled feeding trial of time-restricted feeding and was also the first to combine time-restricted feeding with eating in alignment with the circadian clock. Fasting diets have gained a lot of popularity lately, and there are a whole range of fasting regimes, things like intermittent fasting, alternate day fasting, 5-2 and time-restricted feeding. But the interesting question is whether they actually produce any weight or metabolic benefits compared with conventional energy restriction. I'm delighted to have Courtney explain where we're up to with the science on fasting and the circadian clock. Thank you, Courtney.
Great. Thank you for having me. So I'm going to talk to you today about what we know, the latest research on intermittent fasting and the circadian clock. And I'm going to try to answer the question to the best of what we know. Does when you eat affect your health? So intermittent fasting is the term we use to describe any sort of meal timing intervention or approach that alternates periods of eating and extended fasting. Now, it's important to note there's no one single quantitative definition that all researchers use. So, for instance, those who use a liberal definition will say anytime you fast for at least 12 hours at a time, that constitutes intermittent fasting. On the other end of the spectrum, some researchers are quite conservative and say, well, it's not truly intermittent fasting unless you fast for at least 24 hours at a time. And then most of the rest of us, myself included, are somewhere in between that 12 to 24-hour period. Now, I don't like the 12-hour definition as much myself for the simple reason that if you look at data on median eating habits, for instance, in the United States, the median person or adult is currently eating over a 12-hour period. So I'm reluctant to say that the median person is practicing intermittent fasting. And moreover, I think there's a second consideration, which is, the physiology or your underlying physiology should dictate, what constitutes intermittent fasting. So, for instance, if you look at some of the metabolic changes in the body, in particular at what substrates your body uses for fuel as a function of how long you've been fasting, you don't really see an increase in fatty acid oxidation or gluconeogenesis, or at least above levels that you would expect from glycogen breakdown until closer to about 14 hours of fasting. And so there's this kind of zone right here, maybe 14 to 19 hours of fasting, where you really start to see that increase in fatty acid oxidation, or what we colloquially think of as fat burning. So I like to put that definition a little longer than 12 hours. But just know there's no one single consensus definition. So there have been 6 types of intermittent fasting that have been studied in humans to a decent degree, and we're going to go through all 6 of them today. I like to group these 6 types of intermittent fasting into 3 separate categories, which I think really helps us make sense of them. So the first type of approach are your periodic fasting approaches. So these are approaches where you have a complete 24-hour or longer fast some number of times per week or per month. And the classic example there would be alternate day fasting, or ADF. This is an approach where every other day you have a complete 24-hour fast or abstinence from food. Another classic example, for instance, which is common with religious fasting, is to take, for instance, one day a week to have a full 24-hour fast. The second type of approach, this category is known as intermittent energy restriction, or IER. And these types of approaches, you are typically eating a very low-calorie diet some number of times per week or per month. And there are 4 examples here that have been studied in humans. The first is alternate day modified fasting. In this sort of approach, you typically eat about 25% of your normal daily calories on your fasting days, and you do this in an alternating pattern. So every other day, you're eating about 25% of what you would normally eat. So you can think of that as being equivalent to basically every other day eating one meal per day. Now, the second type of approach in this category that we'll talk about is the 5-2 diet. And that's an approach where you pick 2 days a week to eat a very low-calorie diet. The third type of approach is known as the fasting mimicking diet. And this sort of approach, you typically pick something like 5 days in a row where you eat a very low-calorie diet, and you repeat this some number of times per year, but no more often than once a month. And then the fourth type of approach in this category is known as weekly intermittent energy restriction. And these are approaches where you basically diet for at least a week at a time, and you alternate this with periods where you're not dieting. So you're alternating periods of weekly periods of dieting and not dieting. And then the third category of approaches are your daily intermittent fasting approaches. And these are now known as time-restricted feeding, TRF, or time-restricted eating, TRE. And in this type of approach, you typically eat in a shorter time period each day. And you can do that by either eating breakfast later in the day and or dinner earlier in the day. And then you have a longer daily fasting period between dinner one day and breakfast the next. So intermittent fasting was first studied in the 1930s. We got the first evidence that it can extend lifespan in rodents in the late 1940s. And research kind of petered along for several decades. But we can trace the modern resurgence of interest in intermittent fasting to this seminal study out of Mark Mattson's lab, which was published in 2003. Now, the interesting backstory behind this study is it actually arose from a debate between Mark Mattson, who is the lead scientist on the study, and a postdoc, Michael Anson, who was working on this study. And the debate was whether the benefits of calorie restriction were due to the extended fasting period that often occurred in these calorie restriction studies, or if it was due to the actual reduction in calories themselves. So to resolve this question, they did a study as follows. So they took rodents and they assigned the rodents to one of 4 groups at random. So the first group was a control group. They ate ad libitum, so as much as they wanted, and that's this AL group at the bottom. The second group was an intermittent fasting group, or this IF group, and in particular, they practiced that alternate day fasting that I mentioned. The third group was a calorically restricted group, so equivalent to what a lot of calorie restriction studies were looking at. So it was about 35% reduction in normal calorie intake. And the fourth group was pair-fed, and what that means is they basically ate as much food as the intermittent fasting group, but they, instead of following the pattern of alternating high and low calorie days, they just had a single continuous calorie cut. So every day they were cutting their calories by the same amount. And the interesting thing they found in this study is that the intermittent fasting group did best. They had lower glucose and insulin levels than any of the other groups. And moreover, their neurons in their brain were more resistant to injury. And this was quite interesting because there was a second group, that pair-fed group, that ate the same number of calories as the intermittent fasting group, but the intermittent fasting group did better. So what was so important and groundbreaking about this study is this is the first study to show that intermittent fasting has benefits independent of how many calories you eat. So since then, there's been a flurry of research on intermittent fasting. Most of it's been done in animals. And by and large, the consensus from these studies in animals are that intermittent fasting has a wide range of benefits for what we now call cardiometabolic health. So basically your risk of diabetes and of cardiovascular disease. So in particular, a majority of studies find that intermittent fasting promotes greater weight loss in animals, greater fat burning or fat mobilization, improves metabolic flexibility, so improved ability to switch between burning carbs and fat for fuel, lower glucose and or insulin levels, and just better blood sugar control overall, lower blood pressure, improved cholesterol and triglyceride levels, lower inflammation and oxidative stress, Improved recovery after ischemia, stroke, or myocardial infarction. So in other words, after things like stroke and heart attack. And then longer lifespan and health span, which is true in most animal models tested, but not all animal studies. Now, there are a lot of mechanisms behind intermittent fasting. So in other words, there are a lot of different ways in which we think intermittent fasting is causing these benefits. So for instance, it looks like one of the mechanisms that's responsible for intermittent fasting's benefits is just the fact that you're burning more fat. So if you look at how much fat you're burning as a function of how long you've been fasting, there seems to be this zone a little after about 12 hours of fasting, ranging up to about 24 to 36 hours, where you really see a big increase in how much fat someone's burning. Other mechanisms that have been proposed or may underlie the benefits of intermittent fasting include increased ketone production. So ketones are byproducts of burning fat, and they may help basically preserve muscle mass in the body, and they may also have other benefits for the body. Intermittent fasting also seems to lower insulin levels, which may have benefits. It seems to reduce hunger. There have even been studies that find that intermittent fasting lowers the hunger hormones of ghrelin and leptin. It also reduces the amount of free radicals that are produced. It also seems to reduce just the production of oxidative, or just the amount of oxidative stress in the body. It also seems to just make the body more resilient. So there's a concept called hormesis. It's basically this idea of what doesn't kill you makes you stronger. And so we think some of the benefits of intermittent fasting are from that. You know, it causes a little bit of stress from the fasting, but then your body becomes more resilient. There's also some evidence that intermittent fasting promotes something called fasting natriuresis. And what this is we find that with the longer people fast, the better the body is at getting rid of excess sodium or salt that people are consuming. And so this may naturally lower people's blood pressure. Intermittent fasting also seems to promote cellular recycling or autophagy. And so this may be one of the mechanisms that conveys a lot of the benefits of intermittent fasting. And then it also seems to slow down the aging process. So in particular, there are a bunch of different aging pathways in the body that intermittent fasting seems to improve. And then lastly, more recently, we've even found evidence that intermittent fasting helps with the circadian or biological clock in the body. So the first study that I know of that was done in intermittent fasting in humans was this study published in 2005. It was done by my mentor, Eric Ravison at Pennington Biomedical Research Center. And what they did in this study was basically a 3-week study in 16 people, and they tried alternate day fasting. So every other day, the participants were told to do a complete 24-hour fast. And the interesting thing they found is that participants lost weight in a zigzag-like pattern, as you can see here. So they were unable to overeat or compensate enough to undo the beneficial effects of weight loss on their fasting days. So people naturally lost weight when told to have extended fasting periods. The interesting thing they found is the results for glucose and insulin levels were a bit mixed. They were more favorable for the men than for the women. But the big punchline in this particular study, is they found that participants towards the end of the study had increased hunger levels with no signs of lessening. So in a sense, they were actually hangry, for those of you familiar with the time. So the authors basically concluded that alternate day fasting may not be sustainable and feasible in people. And this is important to note because most of the data we have on intermittent fasting in animals actually comes from looking at this alternate day fasting approach. So a lot of that data in animals just may not apply to humans, or at least may not apply to the more sustainable forms of intermittent fasting in humans. So for actually more than a decade after this study, no one was really considering studying alternate day fasting in humans. But with the resurgence of interest in intermittent fasting, 2 more recent studies have come out, which have compared alternate day fasting to continuous energy restriction. And every time I say continuous energy restriction, you can just think of that as daily dieting. But interestingly, the 2 studies had conflicting results on whether alternate day fasting was better than regular dieting for weight loss. So I think the answer is still out with alternate day fasting, but the preliminary data suggests that it's probably not very feasible for the general public. The second type of approach that's been studied in humans quite a bit is alternate day modified fasting, or ADMF. And this sort of approach alternates fast days where you typically eat about 25% of your daily calorie needs with feast days. So you're technically overeating by about 25% on your non-fasting days. And this type of approach has been most extensively studied by Dr. Krista Vardy. And she's done multiple studies in rodents and humans. And initially, her lab found that alternate day modified fasting induces weight loss, improves insulin and glucose levels, improves blood pressure, lipids, and the inflammatory marker C-reactive protein in humans. They also found that in individuals without a prior history of eating disorders, that alternate day modified fasting did not worsen symptoms of eating disorders. More recently, her lab has done the first large-scale study of alternate day modified fasting in humans. This was a 1-year-long study that was published in JAMA Internal Medicine. And there were 100 participants who were randomized to one of 3 groups. So one group was a control group, and that group did not lose any weight, and that was by design. The second group was a continuous energy restriction group, so they're your basic regular daily dieting group. And then the third group practiced alternate day modified fasting. And both of the last 2 groups were counseled to eat the same amount of calories. So they were counseled to cut their calories by the same amount. And what they found is that if you look at the data on a month-by-month basis, alternate day modified fasting was no better than conventional daily dieting for weight loss. So unfortunately, they found no advantage for weight loss with alternate day modified fasting. Moreover, there were no differences in glucose, insulin, blood pressure, heart rate, lipids, visceral fat, or inflammatory markers. So then you can argue, well, maybe alternate day modified fasting is just an equivalent way to lose weight. So, you could pick either daily dieting or alternate day modified fasting. They're both great for weight loss, or they're both equivalent for weight loss. However, if you look at the fine print in the study, the dropout rate was actually higher in the alternate day modified fasting group. So it actually looks like it's less feasible or less sustainable than conventional daily dieting. The authors also have done an analysis where they went back and looked at their data, and they separated out the effects based on whether individuals had insulin resistance or not. And they actually did find that in individuals who started with insulin resistance, they actually improved more with the alternate day modified fasting. So it may have extra benefits for those who are at higher risk for type 2 diabetes. The third type of approach has been studied in humans, which is also another form of intermittent energy restriction. It's called the 5-2 diet. This type of approach has been studied a lot in the UK. It's very popular due to a BBC documentary on it. So this is a type of approach that involves eating a very low-calorie diet twice a week. So typically about 25 to 35% of energy needs on fast days. So this type of approach has been studied most by doctors Michelle Harvey and Anthony Howell. So they've completed 3 trials. And there's actually been a flurry of research in the last 2 years. So now there are an additional 12 trials by other teams, so 15 trials in humans in total. Now, Drs. Harvey and Howell's seminal trial was conducted in 2013, and it was a 3-month trial in 115 overweight women with a history of breast cancer. And what they found is that the 5-2 diet reduced body fat levels, insulin levels, and insulin resistance more than conventional daily dieting. However, there was no difference in any other fasting cardiometabolic endpoints. So this was one of the first studies we had in humans suggesting that intermittent fasting may have benefits even independent of weight loss, so even above and beyond what you get from daily dieting. In the last year, we've now had 4 new 1-year randomized controlled trials with about 50 to 100 participants per group that have completed. So these are now the longest and largest studies we have on intermittent fasting. Now, what's really interesting about these studies is if, for instance, you look at data from a couple of these studies, what they're often finding is an improvement in weight loss in the short term. So, for instance, on this plot here on the right, you can see that the intermittent fasting group loses significantly more weight at week 12, so about 3 months into the study. But this difference evaporates by the end of the study about a year later. So they were able to trace this back to issues with adherence. So in the short term, participants were very adherent to the 5-2 diet. In the long term, they slipped off it. And so they were no better off 1 year later. But the 5-2 diet may have benefits for short-term weight loss, which is great. However, they didn't find any change in fasting cardiometabolic risk factors, but they did find some evidence for improvements in postprandial C-peptide and triglyceride levels. So in other words, they found that participants seemed to produce less insulin in response to a meal, suggesting that their blood sugar control had improved, and their triglyceride levels weren't quite as high after eating. So that's also important for reducing cardiovascular disease risk. There's now starting to be meta-analyses on intermittent energy restriction and whether that promotes weight loss relative to conventional daily dieting. So there have been a handful of such meta-analyses, and I picked one of them here. So this was a meta-analysis that was published in late 2018. And this meta-analysis identified 11 randomized controlled trials that were longer than 1 month. So these are mainly studies of either alternate day modified fasting or the 5-2 diet. And what they found is that intermittent energy restriction does not seem to affect weight loss. There was slightly greater weight loss with the intermittent fasting, but the result was not statistically significant when you pooled it across the studies. However, repeating the same analysis for insulin levels, they did find that the intermittent energy restriction reduced insulin levels significantly relative to daily dieting. So intermittent energy restriction may improve insulin levels and or insulin sensitivity. And they also found some marginal improvements in HDL and triglyceride levels. So there may be some benefits with this type of intermittent fasting for improving other aspects of health independent of whether you're losing weight or independent of what you're eating. The next type of approach I wanted to talk about, which is gaining a lot of traction, is the fasting mimicking diet, or FMD. Again, this is another intermittent energy restriction approach. So this type of approach involves eating a very low-calorie diet, typically 700 to 1,100 calories a day, for typically something like 5 days in a row. Now, this diet also has the requirement that it's low in protein, so about 10% of protein needs, and that it's plant-based. And then you repeat this cycle some number of times per year, but not more than once a month. And this approach was pioneered by Dr. Walter Longo, who found very impressive results with fasting in cancer patients as well as animal studies of cancer. But he also found that a lot of people were not willing to complete, say, the 48-hour fast needed to get some of the maximal benefits of fasting when combined with chemotherapy. So he designed this fasting mimicking diet as a more sustainable way to implement intermittent fasting into cancer treatment. And in a lot of the rodent studies Dr. Longo has done, he has found that the fasting mimicking diet reduces body weight, reduces visceral fat or the bad belly fat, extends lifespan, reverses type 1 and type 2 diabetes, and increases the number of stem cells and regenerates organs. So they've now completed and published 3 studies on the fasting mimicking diet, and I think there are another maybe 12 ongoing around the world in different countries. Now, only one of the studies was a large-scale study, and I'm showing the data on this here. So they did a study in 100 healthy adults, and what they did is they divided individuals into, they were randomized either to a no weight loss control diet or to do 3 cycles of 5 days of the fasting mimicking diet. So in other words, the participants did the fasting mimicking diet for 5 days in a row, once a month for 3 months. And what they found is that the fasting mimicking diet reduced body weight, BMI, body fat levels, IGF-1 levels, and blood pressure more than the control diet. However, there were no effects on fasting blood sugar levels, cholesterol levels, or inflammatory markers. But we still have no idea how the fasting mimicking diet compares to conventional daily dieting. So this is a much younger area of research within intermittent fasting. The next type of approach are your weekly intermittent energy restriction approaches. So these are approaches where you're typically practicing intermittent energy restriction. So you're doing basically a very low calorie diet for at least a week at a time. And you're alternating that with weeks where you're eating enough to maintain your weight. And this concept, I think, is really quite fascinating because it arose out of some research in Australia by Amanda Sainsbury and other colleagues who are hypothesizing that by interspacing these periods of regular dieting with periods where you're not dieting, maybe you can trick the body into not necessarily adapting to the diet. So you kind of, the body is a little bit, the theory is the body's a little bit shocked by, the fact that you're cutting calories. So it starts to adapt. And so you start burning fewer calories over time. But if you have these periods where you go back to normal eating, maybe you can counteract those effects and get more weight loss long term. So far, there have been 5 trials on this approach, at least 5 trials that were approximately 3 months or longer. And if you look at the data, the pooled data on these types of approaches, it looks like actually the data on weight loss are pretty mixed, but they tend to favor no difference. So we don't have hard evidence that these approaches facilitate more weight loss than normal daily dieting, or at least not yet. And the last type of approach, or the 6th type of approach that's starting to be studied in humans, is time-restricted feeding, or TRF, or time-restricted feeding, TRE. And these are approaches that I study. So these are approaches that involve fasting for at least 12 to 14 hours daily, depending on who you ask. People have different definitions. I think the time-restricted feeding approaches are quite promising in the sense that they're the only kind of class of approaches that doesn't prescribe a specific amount of calories that you need to cut. So they're far more customizable. So for instance, you could take someone who's already close to their ideal body weight, and they don't have to cut calories when they're practicing time-restricted feeding. Conversely, you could have someone who's quite overweight, and they could cut calories to the degree they wanted, unlike the other approaches that say, okay, you have to cut your calories by a certain amount on these days. I think these types of approaches are much more customizable. And the study that really put time-restricted feeding on the map was this study out of Sachin Panda's lab at the Salk Institute, which was published in 2012. So in this study, they randomized mice to either eat within an 8-hour period or to graze across the day. And furthermore, within those 2 different groups, they randomized the mice to either eat a normal chow diet or a high-fat diet. And what they found, interestingly enough, is that the mice who grazed on a high-fat diet gained a lot of weight, but the mice who ate the exact same amount of high-fat food, but ate that within an 8-hour period each day, gained significantly less weight. And even within the group of mice that ate a normal chow or healthy diet, they also gained less weight when they practiced time-restricted feeding. And in that study, they also found that time-restricted feeding improved blood sugar control, reduced cholesterol levels, reduced the levels of fat in the liver, improved and lowered inflammation in the body, and just had a wide range of benefits. So since that study was published in 2012, there have now been about 4 to 5 dozen studies in animals looking at time-restricted feeding. And the consensus is quite remarkable. So a majority of studies, the overwhelming majority, show that time-restricted feeding reduces body weight and or food intake, prevents and reverses type 2 diabetes, improves cancer outcomes. So there are at least 4 studies now all finding benefits related to anti-cancer effects, that improves cardiovascular risk factors, including hyperlipidemia, so elevated lipid levels, and it also extends lifespan. So there's a really interesting study last year that showed that at least 40% of the life-extending benefits of calorie restriction are actually not due to the calorie restriction. They're due to the instead due to time-restricted feeding or eating in a shorter period each day. Now, I think there are 2 things that make time-restricted feeding particularly promising in terms of from a public health perspective, in terms of having people try this as a public health intervention. So first, the data in rodents suggests that the benefits are proportional to the length of the daily fasting period. So meaning the longer you fast each day, the greater the benefits. And this is great because it means there's no sort of magic cutoff number of hours that people need to achieve to get at least some benefit. And the second is there have been 2 studies now in rodents that have found that following time-restricted feeding, for 5 out of 7 days a week produces much of the same benefits as following it daily. So in other words, people don't have to follow it daily to get benefits. And that's great because I think it would be unrealistic to expect that people would be willing to do it every single day due to, having a social life and so forth. So to date, there have been 14 pilot studies in humans. So another 2 came out in the last week and a half that have looked at time-restricted feeding in humans. And they've looked at eating windows ranging from 4 to 11 hours per day. Now, the really important thing to note about these studies is they're all small or what we call pilot studies. So none of them are definitive enough to make any sort of public health recommendations. All our evidence so far is preliminary. But by and large, the studies have been very promising. So what we found in these studies is that when people eat either early in the day, which we call early time-restricted feeding, or the middle of the day, which we call midday time-restricted feeding, time-restricted feeding seems to improve appetite and or food intake, seems to reduce weight and or body fat. It improves glucose and insulin levels and insulin sensitivity. It also improves fat oxidation or fat burning. It improves blood pressure and it lowers oxidative stress levels. So I want to share data from a couple of those studies right now. So this first of the studies that I want to share you is from Dr. Krista Vardy's lab. So they did a single-arm study in 23 overweight adults, and they had those adults eat within an 8-hour period, starting at 10 a.m. in the morning and ending at 6 p.m. in the evening. And they compared that with data from another weight loss study they had done in the lab. So it technically was not a randomized controlled trial. What they found is that the time-restricted feeding seemed to induce a little more than 2% weight loss over a 12-week period. And while that's not something we typically get excited about, I think the reason we should probably get excited about that here is the participants were not told to cut calories, and yet they naturally lost weight. So I think that's quite promising, either from a weight loss perspective or weight maintenance perspective. They also found in the study that participants were able to practice time-restricted feeding about 5.6 days a week on average. So that's about 80% adherence. So that's pretty good. They also found about an 8-point decrease in systolic blood pressure, and they found no difference in fasting cardiometabolic risk factors. Another example study I want to show you is data from a resistance training trial in adults. So this was an 8-week study of time-restricted feeding in 34 individuals who were practicing resistance training. And those individuals were randomized to either practice time-restricted feeding by eating between 1 p.m. and 9 p.m., so in the middle of the day. And they were compared against individuals who were told to eat throughout the day, so eat over a 13-hour period. And what they found is that the time-restricted feeding reduced body fat by about 1.3 kilograms. It reduced triglyceride levels slightly. It lowered testosterone levels, IGF-1 levels, which is an aging marker, and an inflammatory marker called IL-1 beta. But there were no changes in cholesterol or fasting blood sugar markers. Interestingly, however, in the 2 studies that looked at what happens when you practice time-restricted feeding by eating late at night, those studies found either no benefit or negative effects, that people were actually worse off. And you can think of late time-restricted feeding as equivalent to skipping both breakfast and lunch. And I know plenty of people who tell me that they practice time-restricted feeding by only eating dinner. Unfortunately, the data we have so far suggests that people are worse off. So there may be some slight benefit for weight loss. But if you look at other aspects of health, for instance, one of the studies, which had participants eat between 5 and 9 p.m. at night, found that the late time-restricted feeding worsened glucose levels following a meal, as you can see here on the right. It also worsened insulin levels, blood pressure, and cholesterol levels. So at the moment, we can't recommend skipping both breakfast and lunch. People may be worse off in terms of their health, even if they are losing more weight. And the reason why we think that the time of day that you eat might matter is because you have an internal biological clock called the circadian system. And this system produces approximately 24-hour rhythms in your metabolism, physiology, and behavior. So in other words, it makes you better at doing different things at different times of the day. So for instance, for sports performance, your best coordination, greatest muscular strength, and fastest reaction times are in the afternoon. The best time to sleep is in the evening because that's when your body really starts to produce melatonin, which is one of your sleep hormones and also is a circadian hormone. Conversely, we have the fastest increase in blood pressure in the morning. So that's why we have more heart attacks in the morning than any other time of day. Testosterone levels in males are also highest in the morning. Now, one of the really interesting rhythms, circadian rhythms, that has a very strong time of day effect is your rhythm and your blood sugar control. And this is, again, also controlled by your circadian system or internal biological clock. So your internal biological clock in most people makes you better at controlling your blood sugar in the morning. So, for instance, we've known actually for almost the last 50 years that your blood sugar control is substantially better in the morning than it is later in the day. So if you do the same blood sugar test in the morning, the afternoon, and the evening, your blood sugar levels will spike significantly higher in the afternoon and the evening, despite the fact that you're drinking the same amount of sugar water for the blood sugar test. And in fact, this is such a big difference that what it means in practical purposes is that if you take someone with what we consider normal, healthy blood sugar control in the morning, and then you have them eat dinner, they're actually borderline pre-diabetic when they're eating dinner every day. So that means most people have substantially worse blood sugar control when they're eating dinner every day relative to the morning. And these rhythms are maintained in nearly every cell in the body. So they're maintained by something called a transcription translation feedback loop. So it's basically a bunch of genes with funky names like clock and BMEL and PER and CRY that maintain these loops or these rhythms that involve both the translation of genes and also transcription and translation of genes and their protein products. And this cycle takes approximately 24 hours to complete. And so that's how we get these 24-hour rhythms. And it turns out that up to 50% of all genes or gene products oscillate in at least one tissue in the body. So basically, the punchline is the influence of your circadian system on the health of your body is pervasive. Now, it's interesting, I mentioned that nearly every cell in your body has these circadian rhythms. So you can think of every organ and tissue in the body as having its own clock. We like to group these clocks into two, broader systems. So you can think of the circadian system as having two parts. So the first part is the central or master clock in the brain. And this clock is kind of like your conductor clock for your body. And what's interesting about this clock is its time zone is set by a variety of factors, but one of the most important factors is when you get bright light exposure during the daytime. You also have clocks in the rest of the tissues and organs. We lump them together and we call them peripheral clocks. And one of the really interesting things about these peripheral clocks or clocks in the rest of your body is it seems like their time zone is set by a variety of factors, but one of the most important factors is when you eat. So the punchline is if you're eating out of sync with when you habitually get bright light exposure, it's as if your clocks are in two different time zones. So they give conflicting signals to your metabolism about whether to rev up and to rev down. And as a result, this creates all kinds of problems in your metabolism. And the analogy here with an orchestra is perfect because if you think of the central clock as the master clock, it would be like the different sections of your orchestra are playing out of sync, and they're also out of sync with your conductor. And clearly, you can't make beautiful music if that happens. Now, some of the first data we had that suggests that eating out of sync with these circadian rhythms causes problems is a study out of Fred Turek's lab in 2009. So what they did in the study is they fed mice the same amount of food, but one group was randomized to eat during their normal sleeping period, and the other was randomized to eat during the normal period that they were awake. And what they found is the rodents who ate during their normal sleeping period gained significantly more weight despite eating the same amount of food and exercising the same amount. And that same year, we also got our first human data that eating out of sync with these circadian rhythms can worsen our health. Now, we call this phenomenon of eating out of sync with our rhythms, we might call that like circadian misalignment, but it's this idea that your clocks are not all in the same time zone in your body. So there's a very elegant study led by Frank Shear and Stephen Chea, showing that circadian misalignment increases 24-hour glucose levels by 6%, insulin levels by 22%, blood pressure by 3%, and also worsens your sleep by about 20%. So this was some of our first data that shows if you're, eating and sleeping at the wrong times of the day, even if you're not losing any sleep at all, it basically worsens your health and your metabolism. So then you might just argue, well, what if I just don't eat at night? Does when I eat during the daytime matter? And it turns out it's not just a function of whether you eat or not, eat at night or not. It looks like, in general, eating early in the day is better. So, for instance, there was a study out of Spain. It was a weight loss study with over 400 adults, and everyone got the same weight loss program. The really interesting thing they found is that individuals who ate a late lunch lost weight much more slowly than those who ate an early lunch, suggesting that, even the time of day that you eat your meals within the daytime matters. It's not just a matter of avoiding eating late at night. Also, about a year later, we got a study out of Israel from Oren Froy and Daniela Jakobowicz's lab, testing the old adage of eating breakfast like a king, lunch like a prince, and dinner like a pauper. So they tested that old adage to see whether eating earlier in the daytime affected weight loss and other aspects of health. So they took nearly 100 women, and they randomized them to either eat a large breakfast and a small dinner, or to do the opposite, to eat a small breakfast and a large dinner. And what they found is that the women who ate a large breakfast lost significantly more body weight over a 12-week period than those who ate a large dinner. And moreover, not only did they lose more weight, they were less hungry throughout the day. So I actually see this as the 1-2 punch for late eating, because individuals who ate a large dinner and a small breakfast, in other words, who ate late in the day, not only were they less successful at losing weight, but they were far hungrier. So it's not only that your physiology resists the weight, but you actually even find it harder to lose weight when you eat later in the day. They also did a really nice 1-week study. It's called a controlled feeding study, meaning they provided all food to participants and monitored them in adults with type 2 diabetes. And what they found is after only 1 week of eating breakfast like a king, they found significant improvements in blood sugar levels as well as insulin levels. And in particular, they found that after only 1 week, they were able to restore these patients' ability to produce insulin. So in other words, we know with type 2 diabetes, people lose the ability to produce insulin. They were actually able to reverse that disease process, help people with type 2 diabetes produce more insulin, and in turn, lower their blood sugar control. And this is after only 1 week of changing their meal timing habits. So pretty impressive. And then lastly, they did a really nice study also in women with PCOS, so polycystic ovarian syndrome, where they also tested whether the adage of eating breakfast like a king can improve their health. And in this particular study, they actually focused on fertility. So this was about a 3-month intervention, or about 12 weeks long. And what they found is that the women who were randomized to eat more of their calories early in the day, by the end of the study, nearly 50% of them had regained the ability to ovulate, versus only about 20% in the control group. That's a huge difference. And we now think this makes sense because a lot of the same clock genes that create those 24-hour rhythms in our metabolism and physiology also create rhythms that are shorter and longer than 24 hours in our body, including the menstrual cycle. So I saw some of this data several years ago on both the daily intermittent fasting as well as eating earlier in the daytime, following the old adage of eating breakfast like a king. And I thought, wouldn't it be amazing if we combined the two together? So if we did the daily intermittent fasting by eating early in the day to be in alignment with these circadian rhythms and metabolism. And I call this early time-restricted feeding. And I was quite interested in it because I wanted to push the limits of meal timing and see what's the maximum kind of benefit we can get from changing our meal timing. So early time-restricted feeding, the most practical way you could define it is it's equivalent to eating dinner sometime in the mid-afternoon, say before 4 or 5 p.m., and then fasting the rest of the day. And we have 5 clinical trials in my lab. We've completed 2 small or pilot studies, and we have 3 larger studies in progress. We have a weight loss study. We also have a study looking at to what degree the time of day that you practice time-restricted feeding matters. And then we also have a 3rd study looking at whether we can use time-restricted feeding to treat type 2 diabetes. Before proceeding to that, I did want to make an aside because one of the questions I get asked a lot is, well, how do you make sense of the breakfast skipping literature? And it's interesting because if you look at the best quality evidence we have on breakfast skipping, suggests that breakfast skipping does not seem to affect body weight. However, it may affect 24-hour glucose levels or blood sugar levels. So there have been a number of studies that looked at a single bout of breakfast skipping and found that under a very controlled conditions, actually breakfast skipping does seem to raise blood sugar levels. But I think what's complicated about breakfast skipping is it's not a monolithic behavior. Some people skip breakfast by eating late at night, and some people skip breakfast and they don't eat late at night. So there's some really interesting studies out of Japan that show breakfast skipping is not like a monolithic behavior. About half of people who skip breakfast eat late at night, and the other half of people who skip breakfast don't eat late at night and eat dinner at a normal time. And if you look at their health effects, individuals who skip breakfast and eat dinner at a normal time are at no higher risk of metabolic syndrome or having obesity, whereas those who skip breakfast and eat late have much higher odds of both. So I think the reason why breakfast skipping has been so confusing is because if you skip breakfast and say you eat dinner at a normal time, maybe you're missing out on some of the benefits of eating earlier in the day, so some of those circadian benefits, but you may be gaining some benefits from intermittent fasting. So I think that's why the whole should we eat breakfast or not has been so confusing, and I don't think we have a definitive answer yet about whether breakfast skipping is a problem or not. I mean, I think we have enough data to suggest that skipping breakfast and eating late in the day is problematic, but I don't think we have enough data yet on breakfast skipping when dinner is eaten at a normal time. So back to the main topic. So my lab has done, we've completed 2 studies on early time restricted feeding, and we have another 3 that are in progress. So our first study that's already been published was a 5-week study in men with prediabetes. And the goal of the study was to determine whether early time restricted feeding has cardiometabolic benefits independent of food intake and weight loss. So this was a controlled feeding study, meaning, and it was isocaloric and eucaloric, meaning we fed participants in both meal timing schedules the same amount of food. And then we also made sure they didn't lose weight. And the reason why we did this is we wanted to know whether this early time restricted feeding has benefits independent of how much people are eating and independent of whether they lose weight. Because that's one of the huge questions in the field, which is, does intermittent fasting have intrinsic benefits that are independent of weight loss, or are all the benefits from intermittent fasting just from the fact that you lose weight? So in our studies, which I will show you, our first 2 studies, we had participants try 2 different meal timing schedules. The first was a control schedule where they ate 3 meals in 12 hours. And those meals you can see here, and then they had 12 hours of fasting until the next meal. They also tried an early time restricted feeding schedule where they ate 3 meals, but they ate those same 3 meals in 6 hours. So they had 18 hours of fasting to the next day. So participants in these studies were done eating by 3 p.m. So pretty extreme, but we were interested in the time at just looking at the physiology, not yet looking at what's feasible in people. So just keep that in mind. So what we found in this first 5-week study is that the time-restricted feeding did not seem to affect morning levels of blood sugar. We've since taken those measurements in a separate study over a 24-hour period, and we do see improvements. So we've learned that if you only measure in the morning, you may not see the full amount of improvements in blood sugar. However, we did find an improvement in insulin levels in the morning. So we found a reduction in insulin levels. And when we looked at indices of insulin resistance and beta cell responsiveness, both of those improved. So we found about a 24% improvement in insulin sensitivity, so in insulin's ability to move sugar out of your bloodstream and into your cells. And then we found about a 13% improvement in beta cell responsiveness, which you can think of as the ability of the beta cells in your pancreas to secrete insulin in response to rising blood sugar levels. We also found about a 10 to 11 point drop in systolic and diastolic blood pressure. These are huge effects. So this is about on par with what you'd expect from a blood pressure lowering medication. Now, we did find an increase in triglyceride levels We're not really sure why that is, but we realized in retrospect several months later, because we at first were wondering, is this concerning? Is this not? It turns out that the standard assay you use to measure triglycerides also measures free glycerol. And since we know that the body is burning more fat, it's also producing more glycerol. So this may be a reflection of an increase in glycerol levels. We found no change in the stiffness of blood vessels and no change in heart rate. But we did find a decrease in oxidative stress levels, which you can think of as a form of molecular damage in the body. We also did a second study. This was only a 4-day-long study in 11 overweight adults. And we were interested in this study in trying to tease apart whether the benefits of other intermittent fasting studies, whether the weight loss benefits were mediated by the fact that people were burning more calories, or whether it was because they were eating less. So anytime you have people lose weight, it's because either they're burning more calories or eating less food. And we wanted to know which one is the main reason that intermittent fasting helps with weight loss. So we did a 4-day study in 11 overweight adults, and they spent 24 hours in what's called a respiratory or metabolic chamber. So in other words, we put them in an airtight room and we measured how many calories they burned and how much of that fat was fat versus carbohydrate. And what we found, unfortunately, we found that intermittent fasting does not seem to affect how many calories you burn. So any increases in calories that people seem to be burning during the daytime is offset by a decrease at night. So unfortunately, the rodent studies, which reported that intermittent fasting increases how many calories the rodents burned, we didn't find that to be true in humans. So that's a case where the rodent research just doesn't translate to humans, or in other words, the rodent results are more promising than the human results. However, the good news is we found that the time-restricted feeding lowers the hunger hormone ghrelin in the morning, and it also tended to do so in the evening. We also found evidence that it improves subjective appetite, so it actually made hunger levels more even-keeled throughout the day. The other thing we found in this study is that the time-restricted feeding increases fat oxidation. So if you look at fat burning over a 24-hour period, we quantify that by something called the non-protein respiratory quotient, and lower values indicate more fat burning. And what we found is literally over about a 12-hour period, starting around 8 p.m. at night, the time-restricted feeding group or arm of the study was burning significantly more fat. And this translated into greater fat burning over a 24-hour period. So we're now running a study to see whether this indeed translates into greater loss of body fat levels. So you have all probably seen YouTube videos of people saying they got shredded with intermittent fasting. Whether that's true or not hasn't been proven definitively. We did find an increase in fat burning in the study, and we're now testing whether that translates into long-term loss of body fat. Also in that same study, we looked at blood sugar levels over a 24-hour period. And what's quite interesting is if you look at average blood sugar levels over a 24-hour period, we found that average blood sugar levels were lower in the early time restricted feeding group, and moreover, the spikes in blood sugar were lower. So what's quite interesting is if you look at the data here, so the control group is this gray line, the early time restricted feeding group is this black line. If you look at the second meal in the early time restricted feeding group, which is this peak here, and you look at the same second meal in the control group, blood sugar levels spike significantly higher with the control meal timing schedule. And we think what might be going on here is when you practice intermittent fasting by eating your meals in short succession, your insulin levels are still elevated by the time you start eating your second meal. So your body actually doesn't have to suddenly produce as much insulin to try to keep your blood sugar levels under control. So it doesn't actually have to work as hard, so you don't get as high a spike. So it's kind of a second meal effect for those of you who are familiar with that. We also looked at the effects of time-restricted feeding on different molecular pathways in the body. So some of the highlights that we found the small increase in ketone levels in the morning. So this is nowhere as large as what you get with nutritional ketosis, but it does suggest that intermittent fasting can increase circulating ketone levels. We found a non-significant decrease in IGF-1 levels, which is a marker of aging, and we tended to find an increase in a hormone called BDNF, which helps protect brain cells. We also found some positive changes in cortisol levels with the time-restricted feeding, suggesting that may in turn improve our circadian clock. And then we found some of the classic indicators of aging were also improved. So we found SIRT1 gene expression was higher in the morning, and we also found evidence for more autophagy or cellular recycling. So we're pretty excited about that. And then lastly, we saw wide sweeping changes in circadian clock genes, suggesting that the clocks in the body were being improved by this meal timing strategy. So in closing, I just wanted to summarize everything we covered today. So we covered 6 different types of intermittent fasting strategies, and then we also talked about meal timing within the daytime. And here are, I think, the major take-home messages. So first, alternate day fasting is likely not sustainable based on the data I showed you because hunger remains elevated. So I don't currently recommend it, although I will say more research is needed in this area since the results are not definitive. Alternate day modified fasting, or ADMF, appears to be as effective as conventional dieting for weight loss and improving cardiometabolic health, but it appears to be harder to stick with than conventional dieting. So probably at this time, I wouldn't recommend it, or at least not for most patients. The 5-2 diet improves insulin levels and reduces body fat levels more than conventional dieting, but appears to be no better for weight loss and improving cardiovascular health, at least in the long term. So there may be short-term benefits at 3 to 4 months, but those benefits don't seem to persist at time periods of 1 year and longer just due to adherence. The fasting mimicking diet appears to reduce body weight, body fat, and to improve other aspects of health, but we have no idea how it compares to conventional dieting, so we can't recommend it yet relative to conventional dieting approaches. And in general, the way I interpret a lot of this data is it seems like most of the benefits of intermittent fasting derive from cutting calories, so it's only marginally better than conventional dieting. So it seems like with a lot of intermittent fasting programs, most of the benefit is really just from the weight loss. So that's my reading of our current research. And I would say overall, I think the data on intermittent fasting from rodents has been a little more promising than what we've seen in human studies. That said, I think there's some approaches, intermittent fasting approaches, that we're going to find to have far more benefits and or be far more sustainable in humans. So in particular, I think time-restricted feeding or time-restricted eating is very promising for improving cardiometabolic health. And my lab has been able to show that it has benefits independent of whether you lose weight. So even if you're not losing weight, it has benefits. So this suggests that at least for time-restricted feeding, much of its benefits are not due to the weight loss. It seems to have these intrinsic benefits. I'm also quite bullish not only on time-restricted feeding, but these circadian-based meal timing strategies, such as eating dinner like a pauper. And you may have a lot of clients in particular who are like, I can't change the timing of my meals. And for people like that, you can encourage them to eat a larger breakfast, a larger lunch, and then a smaller dinner. And these circadian-based meal timing strategies do appear to be superior to conventional daily dieting. So they do seem to have more benefits than conventional daily dieting. I'll also say that breakfast skipping is not a monolithic behavior, and we still need better controlled studies to understand it. I don't think we have a definitive message that we can give to the public. And then lastly, in general, more research is needed on the effectiveness and feasibility of different intermittent fasting and meal timing strategies. And lastly, I'd just like to close by acknowledging the people who made this possible, including our funders and our grant support, as well as the people in my laboratory and our collaborators who made these studies possible. Thank you.
Thank you so much, Courtney. That was fascinating. The whole area of chrononutrition is really taking off, and it's such an interesting area, and it really makes sense that we're designed to be doing certain things at certain times. I work in clinical practice, and one of the really common things I find with the clients who I see who are overweight is that they have incredibly disordered routines through the day. So they don't have a regular time for any meals. They very often have irregular sleeping. Do you know anything about resetting your circadian system? Like, is it possible for these people for their clocks to be reset?
Absolutely. So there are two things they need to do. So one, they need to get enough bright light exposure during the daytime. And current recommendations are at least an hour of outdoor light or bright light therapy per day. And early in the daytime is also good, also better for light exposure too. And then the second thing is just having regular meal timing patterns. I didn't talk about it in this talk, but there have been 2 studies that have found just improving the regularity of meals improves health. I forget what exactly they looked at in those studies, but just getting regular with meals and getting outdoors or using a bright light therapy box.
Yeah.
That'll help reset your circadian rhythm.
Yeah, and it's interesting because it even seems to upset so they end up with kind of gastrointestinal problems. Like the digestive system doesn't know when it's awake, when it's asleep. It's really, anyway.
Okay.
Yeah, but they're good tips. And I quite often suggest people even set an alarm on their phone, and they say they don't feel hungry, but you need to kind of push through that.
Yeah.
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 Can you give me an example of the breakfast a king might eat? When you say breakfast like a king, what would you suggest?
Yeah, so the particular study I was referring to, what they did is it was a weight loss study. So the women, the first one at least, they were counseled to eat 1,400 calories, which is not a lot, but it was a weight loss study. So for instance, they ate 700 calories for breakfast, 500 for lunch, and 200 for dinner. So they're eating like 3 times more calories for breakfast than for dinner.
Yeah, that's right. That's
it's
quite
a huge difference.
Yeah. And are we worried about the macronutrient composition, like how much protein, fat, carbohydrates in it, or just a mixed meal?
Yeah, so there's a little bit of data on this suggesting that it's better to eat your fats earlier in the day, but it's not strong enough to make a recommendation yet. Those studies are not high enough quality. Sometimes I've cited that in talks and people are like, great, I'll eat ice cream and drink wine for breakfast. Not quite.
No. Yeah. It's interesting. With the time-restricted eating and intermittent fasting, the blood pressure results are fabulous, aren't they? Because there's so much there's so much issue with people with blood pressure. Like it really is the number one risk factor for heart disease and cardiovascular disease. But we often kind of forget about it, I guess, because as dietitians we don't see that we can do much about blood pressure. But it's interesting that fasting really does seem to bring down blood pressure and sodium. So that was good to be reminded of that, and even to learn about that. Yeah,
and just talking to other researchers, it's the most consistent finding we're finding. I mean, we're just all seeing huge blood pressure lowering effects.
Yeah, it's interesting.
I mean, even more than the blood sugar effect.
Yeah, I had someone talking about low carb diets a couple of weeks ago, and she mentioned the sodium. It's huge. So people excrete a lot of sodium when they're on a low carb diet, and I wonder if, I don't know, there may be other mechanisms going on. Might not necessarily just be the low carb. They're excreting sodium, maybe reduced glucose. Who knows? Is there a book?
Right.
Is there a book coming out that's Courtney? Everyone's doing a time restricted eating diet book or something. Or you can't tell me.
I mean, I'd love to write a book at some point, but I'm so busy, to be honest, just trying to keep my studies up, as you can probably tell by my sporadic email responses. But Sachin Panda has a book called The Circadian Code, and Walter Longo has a book, and so does Krista Vardy. But I'd love to write a comprehensive book because I also see inaccuracies, people actually misdefine a lot of terms in intermittent fasting all the time, and I cringe. They'll start saying, intermittent fasting involves fasting for 8 to 12 hours a day. And I'm like, oh, there's so many other types, and I just see problems like that all the time. But so it goes.
Yeah. Anyway, thank you so much. Thank you so much.
Courtney.
That was fascinating. Well, and thank you everyone for listening, and take care and all the best with your nutrition practice.